Welcome to the second video on engineering the enterprise semantic layer. In today's video, we will be uploading a given physical data source schema in SQL and transforming it automatically through the platform into an RDF representation of it. So what we see here on the landing page here is a catalog of different physical data source schemas. Some of them are in JSON, some of them are in SQL, some of them can also be in CSV or in DDL. So the idea will be that we will catalog them and have them all explicitly represented in RDF and made accessible through this interface. So next step, what we can do here is, let's say, start importing one physical data source schema. This can be done through the UI or it can be done through an API. So the file that we will be importing is going to be this data warehouse marketing campaign analytics schema. As we can see, the schema will have a set of different tables, and the tables will have different columns, and then also the columns will have different constraints on primaries and foreign keys on how to join these different tables. In the case that the user would want to access this information via SQL, this could be then done by this provided metadata. So the idea is we will take this file, we will just simply upload it here over the UI, and it will be then explicitly represented in RDF. So now next step is I will just simply drag and drop the SQL file. As we can see there, the marketing analytics data warehouse SQL file is going to be uploaded. This is also going to be the name for the schema, which we are going to be here selecting. And this has been now uploaded successfully. So now we will see the results is simply this data source schema as we saw in the file previously, but now represented as RDF. So now it's a knowledge graph. So here we can see that we do have all of these different tables. All of these different tables will now be represented in RDF with their explicit relationship also to columns. For example, here, if we click, we see that there are different columns attached to this table. For example, this table will have a user ID, and we also will know that the table will have also here different primaries and foreign key relationships to other tables, right? So if we wanted to, let's say, join these two tables, it would be through this primary key, and through this relationship we will be able to join two different tables from this schema. So all of this metadata and information is represented in RDF. Why? Because we will then map it explicitly through schemas to the business object ontologies that we have created. So at the end, both users and AI can navigate through this technical path, which is a technical logic that basically developers understand, but through these business definitions that will come to the ontology. The idea will be that all of these encrypted definitions, as we can see here, for example, let's say the names of these tables, or even from some of the columns, which might be only understandable by, let's say, those people that manage these schemas, for example here ds_CRT, right? All of these contain data, so the idea will be mapping explicitly the names and the definitions of these technical names from the schemas to business object ontologies, elements that are semantic. So then both we and AI can, through those semantic definitions, access these different technical names, which are the one that indeed store the data in enterprises. Thank you for watching, and see you in the next video.